Okay, we'll start section 7.4 now, and really the rest of chapter 7 is all about trig identities. Now, when it comes to identities, first of all, what we mean by an identity is if you have an equation that is true for all x values, okay, or all theta values, whatever the variable is, then you call that an identity. Okay, now we've actually already seen some identities. We've talked about the reciprocal identities, and these were identities that we were using to define cosecant theta, secant theta, and cotangent theta. Okay, you're going to take the reciprocal of sine theta, the reciprocal of cosine theta, the reciprocal of tangent theta. There's also the quotient identities. Tan theta can be defined in terms of sines and cosines, sine theta over cosine theta. Cotangent theta can be defined as cosine theta over sine theta. And then there's the Pythagorean identities. These three Pythagorean identities are ones that I'd like you to know. All right. Actually, when it comes to identities, these are really the only identities that I would like you to know. And in class, I would have said that those would have been the identities that I would have wanted you to memorize. Okay. So now there are other identities that you will want to have memorized when you get to calculus, but those won't come until later on, obviously. And I'll point out some of those later on in the chapter once we get there. But really the rest of the chapter is going to be all about identities. Okay. Now in section 7.4, we're going to be establishing identities. I want you to think of this section as really just kind of a computational exercise where we have a situation where we have, one side of an identity, and we're going to algebraically manipulate that to get to the other side. Okay, these are not identities that you have to have memorized or anything like that. It's really just computational exercises. We will then talk about some other identities to finish up the chapter, and I'll be, mentioning some other things once we're at that point. So let's take a look at establishing some identities. I've got a bunch of examples here that we'll be working through. And now when you're establishing an identity, again, think of this as a computational exercise. You are not solving for x. You are not solving for theta. Some students will want to do that. Don't do that. You are just simply starting with one side, and you are algebraically manipulating that to get to the other side. Okay? Now, it's almost always preferable to start with the side that is, containing the more complicated expression, and then manipulate that side to get to the other side. So like in this identity here, if I want to prove that this is true, and that's what I mean by establishing identity, prove that this is true for all theta values. Okay. Well, when I look at this, the left side looks more involved than the right side. So it would make the most sense to start with the left side and work my way over to the right side. Okay. In this problem, why don't we convert everything to sines and cosines? Now, we're going to be using the identities that I would like you to know, okay, the reciprocal identities, the quotient identities, and the Pythagorean identities. Those are the only identities that I would like you to know at this point. So in a problem like this, I'm going to switch everything to sines and cosines. Cotangent theta is the same as cosine theta over sine theta. Tangent theta is the same as sine theta over cosine theta. Inside the parentheses, if I then get a single fraction, cosine theta times cosine theta is cosine squared theta. Sine theta times sine theta is sine squared theta. My common denominator there would be sine theta cosine theta. Now, sine squared theta plus cosine squared theta is 1. Okay, that's one of my Pythagorean identities. And so now I'm looking at sine theta times 1 divided by sine theta cosine theta. Well, the sine thetas will cancel there. That'll leave me with 1 over cosine theta, which by definition is how we define secant theta. And that's where I had to get to. I had to get to secant theta there in the problem. Now, when you're establishing identity, there is not just one way to do the problem. Okay, there are usually many different options. All we're looking for is just an algebraic manipulation to get from one side to another side. So like in this problem here, like I could have distributed the sine theta term rather than just working inside the parentheses. That would have been fine. Okay, as long as I'm still getting to the same conclusion there. That's all we're looking for. Here's another example. I want to establish this identity. Okay, 1 minus cosine squared theta. Well, I know that sine squared theta plus cosine squared theta is 1, right? And so 1 minus cosine squared theta, that would be sine squared theta. Now another Pythagorean identity is this one here. Cosecant squared theta minus cotangent squared theta is 1. We've looked at that in the last chapter. Well, that's going to mean that cosecant squared theta would be the same as 1 plus cotangent squared theta. Okay, so if I use those two Pythagorean identities, and I know that cosecant theta is the same as 1 over sine theta, so cosecant squared theta would be the same as 1 over sine squared theta. I'm multiplying that by sine squared theta. The sine squared theta is canceled, and that gives me 1, which is where I had to get to on the right. Okay, here's another example. Let's start with the left side and work our way up to the right side there. Now, usually what I'm doing in the process of algebraic manipulation here is I'm trying to select like one part of the other side that is like a goal to get to. Okay, it's very difficult to kind of just see the whole thing all at once and try to go right to the answer type thing. Okay, I wouldn't recommend doing that. Okay, some of it's like follow your nose, simplifying. Some of it's, getting creative with it. We'll see that a bit later. But try to select one part of the other side that you'd like to try to get to. Okay, so like here, I see I'm leading off with a 9 secant squared theta, and I have a 4 secant squared theta. Well, 4 secant squared theta plus 5 secant squared theta would give me 9 secant squared theta, right? So if I can try to get the 4 secant squared theta into the mix somehow, that would be ideal since I have a 4 secant squared theta term that I'm trying to get to on the other side. 5 would be in common to these two terms, so I can factor that out. And now here's another identity. Secant squared theta minus tangent squared theta is 1. That's another one of our Pythagorean identities. 5 times 1 is 5, right? So I've got 4 secant squared theta plus 5, and yeah, that's where I had to get to. Okay, now at some point in the process of algebraic manipulation, you will be using one or more of these already previously known identities. Okay, so consider that as part of the plan in this. Here's another problem. Okay, now when I look at this, if I start with the left side and I try to get to the right side, in the denominator I have a 1 leading off. Okay, in the denominator on the right, I have a cosine squared theta term leading off. So I'd like to turn that into a 1. Well, if I multiply the top and the bottom by 1 over cosine squared theta, I'll get that 1 that I need leading off. Okay, so let's start with that. Sine theta times cosine theta times 1 over cosine squared theta. Well, this cosine theta will cancel with one of the cosine squared theta terms that are in the denominator. That would still have one more cosine theta term in the denominator then. And I've got sine theta over cosine theta then up top. Well, that looks good because I know that that's tan theta, right? In the denominator, if I distribute 1 over cosine squared theta into these terms, I'm going to get that 1, which is what I wanted to get to begin this problem here. Sine squared theta over cosine squared theta. Well, sine theta over cosine theta, that's how we look at tan theta. That's one of my quotient identities. So sine squared theta over cosine squared theta would be tangent squared theta. And yeah, that's where I had to get to, right? Tan theta over 1 minus tan squared theta. Okay, here's another one. We'll start with the left side, and we'll try to get to negative cosine theta. Well, let me begin by getting a single fraction here on the left. So I have 1 minus cosine theta times 1, and then minus sine squared theta all over 1 minus cosine theta. Now the next thing that I'd like to do is get everything in terms of cosine thetas. Okay, since I've got to get a negative cosine theta, I don't want this sine theta term hanging there, okay, or sine squared theta. Well, sine squared theta plus cosine squared theta is 1. So 1 minus cosine squared theta, that would be the same as sine squared theta. Now you're subtracting sine squared theta, so I want to be subtracting the quantity 1 minus cosine squared theta, because I want to then distribute the negative into these terms here. 1 minus 1 is 0. Okay, so those terms conveniently cancel for me. And I like that everything is in terms of cosines here. That's what I wanted to do. If I factor out a cosine theta, actually a negative cosine theta term, then in the numerator, that'll leave me with 1 minus cosine theta, which I can then cancel with the one that's in the denominator, and I'm left with negative cosine theta then, which is where I had to get to. Okay, so some of this, like I said earlier, is just kind of some simplifying. Okay, all I'm doing here is I'm getting a single fraction. I've used one identity. I've factored out and canceled. Okay, so not heavy algebra. Okay, but it's you know simplifying and using these identities here. All right, let's try another one. Okay, here's another identity that I've got to establish. I'll start with the left side. And why don't I go ahead and split this into 4 fractions. I've got 2 fractions. Let me get 4 fractions here to begin. Okay, sine theta over sine theta, that's 1. I'm adding cosine theta over sine theta, and then minus cosine theta over cosine theta, that's 1. 1 minus 1 is 0. Okay, so those conveniently cancel for me, right? And then minus a negative means plus sine theta over cosine theta. All right, so just by splitting this into 4 fractions, now I'm looking at, and having these cancel, now I'm looking at cosine theta over sine theta plus sine theta over cosine theta. Now keep in mind where you're trying to get to here, okay? So if I get a single fraction now, cosine theta times cosine theta is cosine squared theta. Sine theta times sine theta is sine squared theta. And my common denominator there would be sine theta cosine theta. Cosine squared theta plus sine squared theta is 1. And I've got 1 over sine theta, which is the same as cosecant theta. 1 over cosine theta is the same as secant theta. Okay, well that's where I had to get to then, cosecant theta times secant theta. Okay, here's another one. Now sometimes these identities involve a little bit of creativity, okay? So like in a problem like this, I'll start with the left side and I got to get to the right side. Now when I look at the right side, I see there's a 1 plus sine theta term in the denominator. So maybe I can begin the problem by getting a 1 plus sine theta term in the denominator. Well, if I multiply the top and the bottom by 1 plus sine theta, then I'll have that there, right? You can FOIL out the numerator. The signs alternate here, so the middle term is going to go to 0, and you're going to have 1 minus sine squared theta. Well, sine squared theta plus cosine squared theta is 1, so cosine squared theta, that's going to be the same as 1 minus sine squared theta. And okay, well I need to get a cosine theta term up top. This cosine theta term in the denominator, I can cancel that with one of them in the numerator, and that'll leave me with cosine theta up top, and I've got the 1 plus sine theta term in the denominator, which I had planned to get early on in this problem. Okay, so sometimes there's going to be a little bit of creativity, but again, you know, keep in mind maybe it's ideal to look at the other side and select like one part of the other side that you'd like to try to, you know, get to, okay, or algebraically manipulate to get to. Okay, here's another example. This one's going to be similar to the last one, so I'm going to start with the left side, get to the right side. Now on the right side, I see there's a cosecant theta plus 1 term in the denominator, and I don't have that in the denominator on the other side. So if I begin by multiplying the top and bottom by cosecant theta plus 1, then I'll have that expression there in the denominator. And so that's what I've done. If I FOIL out the numerator, the signs alternate there, so the middle term would go to 0, and I'm going to have cosecant squared theta minus 1. Well, again, another identity that we should know is cosecant squared theta minus cotangent squared theta is 1. So cotangent squared theta, that would be the same as cosecant squared theta minus 1. Okay, and I'm using that Pythagorean identity then. This cotangent theta term in the denominator I can cancel with one of them up top, and that'll leave me with a cotangent theta term up top, and that's what I need. And of course I still have the cosecant theta plus 1 term in the denominator then. Okay, I think there's a few problems with like logarithms involved also. So of course in a problem like this, like if I start with the left side, I want to make sure I remember my laws of logarithms, okay, because I'll be using that here. Whenever you're subtracting logarithms with the same base, you can combine that to a single logarithm by dividing the inner terms. Okay, now I need a single logarithm here on the right, so you know I'm wanting to combine these now. Divide the inner terms here. So let's see, I guess I didn't show my work with that, but if I have ln of tan theta over secant theta, well, tan theta is the same as sine theta over cosine theta. Secant theta is the same as 1 over cosine theta, right? So if I flip the denominator, the cosine theta terms are going to cancel there. And so that's going to give me ln of sine theta, which is where I had to get to. Now in my calculation, I guess I switched everything to sines and cosines. And that's another option that you could take here. Tan theta is the same as sine theta over cosine theta. Secant theta is the same as 1 over cosine theta. I guess I'm using that. Okay, and then I have split these into 2 logarithms so that I could cancel these last 2 terms, and I still get ln of absolute value of sine theta. Now, so here'd be another option. I guess maybe this would be an easier way now that I look at it, again. But again, there's for these, there's usually multiple ways that you can do these problems. So as long as you're just correctly getting to the other side, using algebra and using other identities, that's really all we're looking for. Okay, the homework is on page 488 when we're now done with section 7.4.